My name is Yolanda Gloria, and we're going to be talking about the 4 steps of urine formation. I started off with a portion of the kidney, and it's an enlarged image of the inner portion of the kidney. So our kidneys are made up of these pyramids or columns, about 4 to 6 of them in each kidney, and they hold the nephrons that are used to filter out our blood to create urine. So there's layers to this. We have the renal capsule, which is the outer layer, the renal cortex, which is the surface closest to, the tissue closest to the surface of the kidney. And then you have the medulla, which includes these pyramids and columns. So we have about 1 million nephrons that filter the blood to create urine in our kidneys. There are 2 types of nephrons. So we have the cortical nephrons and the just medullary nephrons in our kidneys. The difference between these 2 is the number 1, the cortical nephrons are smaller in size. The majority of it is in the cortex of the kidneys, and they are surrounded by pituitary capillaries. They have a short loop of Henle, which is the portion that kind of loops into the medulla, and it produces most of our urine. And then the just medullary nephrons make up about 20% of our nephrons, and their loop of Henle is a lot longer, and it goes deep into the renal medulla section of the kidney, and they help to maintain proper salt and water balance. So again, this is just a portion of the kidney, a little showing one pyramid. On the other side of this photo, I'm going to supersize this area here that goes more in detail on how the blood is filtered. So we have, again, 4 steps of urine formation, and we have the first step is filtration, then we have reabsorption, secretion, and water conservation. So this portion is a nephron, just imaged a little bit better, kind of detailing the sections. So at the beginning here we have the afferent artery that goes into the glomerulus. In the glomerulus is where the filtration starts. So you're going to start to filter out small, anything small enough to filter out of the glomerulus is going to go into the glomerular capsule, and then it's going to start traveling down the path to get filtered. But you have the afferent artery that goes in, and it starts to filter in the glomerulus, and then you have the blood that comes back out, the efferent. The efferent is what will continue to wrap around the entire portion of the nephron, that helps with the secretion, the absorption of the nutrients in that throughout the process. So again, once it goes to the glomerulus, it's going to go into the capsule, and it's going to work its way over to the PCT, which is the proximal convoluted tubule. I know I didn't say that right, but it's PCT. So in this portion is where we will start to reabsorb important solutes and nutrients back into the blood. It's done by a variety of ways depending on the type of solute. So it can be reabsorbed by active, passive, transport, osmosis, endocytosis. Reabsorption is also done by the pituitary capillaries. So again, it's going to be wrapped around this whole portion of the nephron. And it helps with the reabsorption at the PCT. So it's going to reabsorb like glucose, sodium, potassium. It's going to work its way down the nephron loop, which is a part of where the secretion will occur. And it also, secretion is occurs in the nephron loop and also the DCT, which is the distal covulated tubule. So it removes additional waste that was missed when the first filtration of the blood happens. So it'll remove like urea, ammonia, bile salts, drugs, and at this point the filtrate is more like urine. The DCT area does use hormones to help maintain balance of the salts in water. It uses aldosterone, ANP, and ADH. During water conservation, in this step, our body will do only if we need to keep more water in our system, depending on our body's hydration at the time. So it keeps us from becoming dehydrated. This is done at the loop of Henle by, it's called a mechanism, it's a counter current mechanism. So this is something that's opposite flow of filtration that works together to keep water and salt balanced. As salt leaves in the ascending limb, water is going to leave in the descending limb. So retaining water that we need. The vasa recta, which is the area that helps the loop of Henle in the justa medulla nephrons, will also help with the reabsorption of water. In the DCT and the collecting duct, if there is a presence of a hormone called diuretic hormone, which is the ADH hormone, then it knows that the body needs to reabsorb some more water from the filtrate before it's passed through to the urethra. So this will help with dehydration. But if we have enough water, then the extra water will be let out through the urine